Okay, so there's always a whole bunch of stuff that's going on anytime. What is the degree of the numerator? What is the degree of the denominator? Okay, so that means we have what type of horizontal asymptote? We have none, right? Because now the other thing is that it's the denominator is one less. So that could mean two things. We're either going to have a point of discontinuity or we're going to have an oblique asymptote. That's what that means, okay? So it's up to us. I see a whole bunch of I see a whole bunch of stuff going on, so it means that we're probably going to need to factor, okay? So we're going to factor the numerator, we're going to factor the denominator. So in the numerator, I have 4, so we're going to factor by grouping. To factor by grouping, we're going to put grouping symbols around the first 2 terms and then grouping around the second 2 terms. Okay? And then you guys, what do you notice about the denominator? Right, so it's a square one, so it's a difference of squares. So a difference of squares would be what? You got it, perfect. Now, unfortunately, we're not done with the numerator. We still have to do some stuff with the numerator. Okay, so do you see anything in common in the first parenthesis? Do they have anything in common in the first parenthesis? X squared. So we're going to pull out an x squared. And then what's left over in this set of that parenthesis? X plus 2. So x2 times x would be x to the third. X squared times 2 is 2x squared, so that works. What does negative 9x and negative 18 have in common?
Negative 9.
Okay. And I'm left with x plus 2. You know you did it correctly if these 2 parentheses match up. Okay, I'm still not done. X squared minus 9 times x plus 2. Do you see anything that we could factor again?
X squared minus 9 is x plus 2x minus
1. Okay. So we finally factored the entire thing out. Now before we can start canceling out, we need to find our vertical asymptotes, okay? Remember, before you cancel anything out, before you find those obliques or anything like that, you need to make sure you find your vertical asymptote. Okay, so how many vertical asymptotes am I going to have for this problem? 2, because I have two things in the denominator. So I'm going to have x minus 3 equals 0, which is x equals 3. I'm going to have x plus 3 equals 0, which means x equals negative 3. So now remember, those are my vertical asymptotes unless they cancel out. If they cancel out, they become points of discontinuity. So now can we cancel stuff out? We're going to cancel out what? X minus 3 and x minus 3, and then we're going to cancel out x plus 3 and x plus 3. And what am I left with? Now, because things cancel it out and you're just left with that, there are no oblique asymptotes. You guys, if there was, you would know if there was going to be an oblique because because nothing would cancel out. And that's what happened with number 4 and 5. Nothing canceled out. Okay, let's go ahead and graph this. Now, you guys, this time we actually have 2 points of discontinuity. We have one at 3 and one at negative 3. So when we get to 3 and when we get to negative 3, we should have open circles. So let's go ahead and graph this. So again, you guys, I'm just lightly going to put in a line for both of my vertical asymptotes. Now remember, yesterday we had 2 vertical asymptotes, but they actually stay. These are not going to stay because we have a line. I'm just putting them in there so that I know if I cross them, I need to put my point of discontinuity. So I'm going to start at positive 2. My slope is 1, so that means I'm going to rise 1 and run 1. So up 1 to the right 1, and I'm going to keep going. Oh, but see, I'm about to cross that line, so I'm going to put a circle, and then I'm going to keep going. Now, when I'm done graphing this line, you guys, I'm going to go in and erase my vertical asymptotes because they're really not vertical asymptotes. They've become point of discontinuity. And remember, when you go to graph your line, you guys do not put your line through the points of discontinuity. So it just means there's a little break in that line at 3 and negative 3. Now again, you guys, the only reason I put the vertical asymptote in there is so I would know where to put my point of discontinuity. It becomes a discontinuity because it canceled out in the denominator. So it's called a hole in the graph or a point of discontinuity. So there's either y equals 0 as your asymptote. You either have a leading coefficient or when the horizontal, when the numerator's degree is greater than the denominator's degree, you have that none. Those are where all the little ones come in, okay?